Okay, good morning, class. So today we're looking at Euclidean geometry. We're looking at the examples for exercise 9.4. Okay. At this point, we spoke about, we just proved the theorem that says that angles are tended by the same chord, by a chord or arc at the circumference of the circle on the same side of the chord are equal, or angles in the same segment of the circle are equal. We went on and we proved, given that the circle center O and chords or arc AD subtend angle ABD and ACB. We just proved now that angle A is equal to angle C. Or in this case we use angle AN, angle D. It's the same thing basically. Okay, and the converse is also true from okay. The polarities, spoke about that as well. Now we're going to example 1. Example 1 is on page. Exercise 9.4 is on which page? 290? 293. The exercise. 293. And the example, this example is on page 290. 292. Okay. So here we are told that given A, B, C, and D are 4 points on the circumference of the circle. So here we got A, B, C, and girls, you don't mind. A, B, C, and D are 4 points in the circumference of the circle. Chords AC and BD intersect at K. Then we are told that angle A1 is 21 degrees and angle A2 is 44 degrees. Then we are told that angle B is 63 degrees. The first question says, calculate the size of angle D1. We're going to calculate angle D1. Sorry? Sum of triangles. Not so. It's really simple. So we're going to say angle D1 is equal to 180 minus 21 minus 44 minus 63. Okay, 180 minus 21 minus 44 minus 63. Give me an angle of 52 degrees. And the reason is sum of triangles, it is triangle ABD. So here we can write 52 degrees now. Okay. How are you going to calculate D2? Sum of triangles again. You all agree with that? Well, let's look at the triangle. Which triangle is D2 lying in? ADC. We don't have D2 and we don't have angle C. We could get C. But firstly, if we look at BC, this arc here is actually subtending D2. Can you see that? And the same arc is subtending angle A2. What formation do you see there? What do you see? Huh? Do you see a butterfly? Or a bow tie? Okay, you guys are that kind of girls, no? Bow tie kind of girls, okay. Some sees butterfly, some sees bow tie. Okay. You don't see neither, then there's something wrong with your imagination, okay? But what do you see? Do you see that, people? And that is the theorem we just proved now. That if we got an arc or chord subtending an angle at circumference on the same side, What do we know? Those angles are equal. Okay. So what can we say? That angle D2 is equal to 44 degrees. Why? The reason here we're going to use is angles in same segment. It is coming from arc. You see this arc here, or chord? BC. Okay, it's my goal. Angle D2 is equal to A2, yes? But A2 is already given as 44, so why do we just say D2 is 44? So at the end of the day, the question is to calculate the size of, and not ask which angles are equal. You understand? See any confusion? Right. Then in C, they ask you to calculate angle C. Are you going to calculate angle C? Angles in the same segment again. However, it is from this arc now, AD, and AD subtending angle B, AD also subtends angle C. Can you see that, people? The angle C is how many degrees? 63 degrees. Yes? Sorry? Please explain again. Remember, we just proven the theorem that says that if you got an arc and the arc is subtending an angle at circumference, the same arc is subtending that angle at that circumference, then angle A is equal to angle D. Angles in the same segment. Okay. So, with that in mind, you see this arc AD. That arc AD is subtending angle C. That same arc is subtending angle B. Can you see that? So if I must just draw this here, you'll see if you got AD is subtending this angle B here, and that same arc which is AD is subtending this angle C there. So then angle B has to be equal to angle C. You understand? So let's go with it. Of course, angle C is equal to 63 degrees. Why is angle C 63 degrees? Angles in same segment. And it's coming from arc AD. Do I have to write this here? No. As we do not have to write the name of the triangle there, we don't have to say which segment it's coming from or which arc it's coming from. Okay? What do you need to write? You just have to write angle in same segment. Okay? So why do I write this in? So that if you're studying it later by some chance, and then you're a bit confused, and you can see which triangle we're talking about and which arc it's coming from, or chord. Okay. And then D, question says K2. I'm going to calculate K2. Sum of triangles. Okay. So angle K2 is equal to 180 minus 21 minus 52 degrees. Reason? Sum of triangles is triangle ADK. So it's going to give you 73, which is 107 degrees. Could we have said this angle is 90 degrees? No. No? Alright, how else could we have calculated K2? Exterior angle. So K2 is equal to 44 plus 63, which is 107. Exterior angle of triangle, triangle AKB. Could I have said angle at center? That's what I meant. I didn't mean the 90. Did I could go angle at center is equal to twice angle at circumference? Yes. You all agree with that? Who disagrees? Okay, you're all wrong. Under what condition would that be the case if that had to be the center of the circle? Did they tell us it's the center? No. Can you assume it's in the center? No. That is how geometry works, people. It might look like it's a center, but it's not. Unless you are told it is the center, or you have proven it is the center. What is double 63? 126. Was K2 126? No, it was 107. So again, when can we say that K2 is double angle B? If K is given as the center of the circle, we have proven it. Okay. Any confusion there? Alright, let's look at the next one. Example 2. Example 2 is on page? Same page?
Yes.
Okay. Given AB, AC, AD, BC, BD, and DC are chords of the given circle. Then we are told that AB is equal to AD. People, if AB is equal to AD, what do we know? If these lines are equal, what do we know? Sorry? B2 is equal to D2Y. Angles opposite equal sides. Remember, those lengths are equal, so those angles are equal. Okay. Then we are asked to prove that C2 is equal to C1 is equal to C2. We're required to prove that C1 is equal to C2. People, you don't have to do this. Okay? What I'm going to show you now, but it's going to be beneficial for you. Okay? Especially when somebody else is marking your maths paper. Okay? So to prove that two angles are equal, we start off by letting one of the angles equal x. It's easy for us to bring our x into the story, not so? That is always the problem. Not so? So we say, we let either one of these two be x. Okay, so we say let C1 equal. Okay, we always introduce our x to everybody else, not so? She says yes. Okay. Otherwise, where's x coming from? You guys understand? We must, if the x is not on the scene or on the diagram, and we bring it into the story, we must say where it fits in. Okay, it could be x number 1, x number 2, and so on. Okay. So we let C1 equal x. Okay. So now, which other angle is equal to x? Can we say C2 is x? No, why not? We must prove it. We must end off with it. Do not say there on top C1 is equal to C2. No. You must end off with that statement. Therefore, C1 is equal to C2 at the end. Okay. People, which other angle is equal to C1? Any? D2, yes. Why is D2 x? Angles in the same segment. The bow tie. Not so? You guys see that? People, that's how geometry works. Nah? You won't go straight into C1 is equal to C2. You must go somewhere else first and then come back. Okay? So we say D2 is equal to, am I going to say C1 or x? X. Why is that x? We said angle in same segment. And it's coming from arc. How can it be CD? Look here. Which arc is subtending those angles? AB. Can you see that, people? AB, this arc AB is subtending angle D. The same arc is subtending angle C. Can you see that? So which arc is it? AB. People, if you can't distinguish between the arcs and all of those, then you leave that part out. Okay. Right, now which angle is equal to D2? B2. Why is B2 X? Angles opposite equal sides. Good. Right, now which other angle is equal to X? C2. Why? Angles in the same segment. You see here? That angle, you see this arc AD? You can play little games with yourselves, no? Put your finger one there and one there. You say, okay, you run the fingers along the lines. You see here B2 is also equal to C2. You see the bow tie there? So that angles are equal again. Okay? What do we say? Angle C2 is equal to X. Why? Angles in same segment. It's coming from arc AD. AD is arc AD. But what do you notice now? C1 and C2 has an X in it, not so? Yes, sir. So it just conclude therefore angle C1 is equal to C2, which is equal to X. Okay. Easy, no? We'll just play around it. You'll see how easy it is. Okay. Is there any confusion? Is there any confusion? 292. Yo, the fun came to an end so quick. Alright, so no questions. Okay. That the meeting? Any questions? So with that you should be able to do exercise 9.4. So out of exercise 9.4 I want you guys to do numbers 1 to 4. But one girl say, yeah, it's too little. Huh? Cycle test tomorrow, okay. Yeah, just numbers 1 to 4. Okay. Yeah. Of exercise 9.4. Right.